This video explains about solving systems of linear equations in three variables using TI 83 and 84. Since it is a system of three equations with three unknowns, definitely all those three equations will represent a plane, and if those three planes meet at a particular point, then that point will be the solution to that equation. The point of intersection of all those three planes will be the solution to that system. If we have planes like this in the first diagram, like when all three are parallel, there is nothing common to those, in which case that will have no solution. But the diagrams in the second figure and in the third figure looks like any two of them intersect, but not all of them have a common point. That is, any two of those planes may have common points, but not all those three intersect at a single point, or they do not have any common point. In that case, we say that it has no solution. In my first diagram, it looks like all those three planes intersect and they have a line common to that. They all meet in a line, intersect at a line. So points lying on that line will be the solution to this. Since we have got infinite number of points lying on that line, all those points will be solutions. So it has got many solutions. The same case in the second diagram, it looks like all those three planes are overlapping or lying one above the other. In that case, it has a common point. All those points which are common to those three will be the solutions to that. So in both the cases, it has got many solutions. We have already seen the algebraic method in my other videos that describes a substitution method, elimination method, matrix or determinants method. The graphic method is the method what we adopt here. We graph and view the common points or the common point. If you have one just single common point, then it has a unique solution. If it has common point, then it has many solutions. If it doesn't have any point, then it has no solution. We can also use the reduced row echelon form of TI 83 or 84 using a graphing calculator. When we use a graphing calculator, we have to create a matrix using the coefficient and the constant. That is, using the augmented matrix of the coefficient and the constant, we can find the value. We can create it using the second x inverse that gives us matrix and edit. And quit the screen, select reduced row echelon form of that matrix math. Under matrix math, we can search for that reduced row echelon form. If we find, let us graph this system. 3x plus 4y minus z equal to 8, 5x minus 2y plus z equal to 4, and 2x minus 2y plus z equal to 1. So when we graph this, it looks like all those three graphs, the planes, meet at a single point, and that point happens to be the solution. The solution is 1, 2, 3. We are able to get the solution by just observing the graph. Maybe we can also check that using a graphing calculator and see whether we get the solution for this same system what we had. So we have this equation 3x plus 4y minus z equal to 8, 5x minus 2y plus z equal to 4, and 2x minus 2y plus z equal to 1. When we use our graphing calculator matrix, we can edit those matrices and find the reduced row echelon form. It gives us the reduced row echelon form of this matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. That is the unit matrix. And the last column, the constant column, is 1, 2, 3. And that will represent the values of x, y, z. So our x is 1, y is 2, and z is 3, which is the same as the solution what we got by just graphing it. Next, let us graph this system we have got again three equations with three unknowns. So all these three will represent planes. It looks like when we graph it, not all, we do not have any common point for all three. Any two, when I take two, the first two are parallel and then it intersects with the other one, but we do not have anything common for all three. So it has no solution. We can also check this using our graphing calculator TI-83 and 84. So using TI-83 and 84, by editing this matrix, entering this matrix, augmented matrix, and finding the reduced row echelon form, we get the reduced row echelon form as this. And it looks like from the last row, we get a solution 0 equal to 1. But we know that 0 is not equal to 1. It is not true. Since 0 is not equal to 1, this equation is not true, and hence it has no solution. Next, let us graph this system and see what is the point of intersection. When we graph this, it looks like all those three have common points. So since they have common points, they are all one and the same, this system has got infinite number of solutions. Maybe we can check this using our graphing calculator again. By using our graphing calculator, we can enter this augmented matrix in the matrix edit mode and then find the reduced row echelon form. We get the reduced row echelon form of like this, and we say that it has an infinite solution. Why do we say that it has infinite solution by just observing this reduced row echelon form? It's because when we took this equation and got the reduced row echelon form, we got the matrix as 1, 1, 1, 2, which may be true, but the last two rows are 0 equal to 0, 0 equal to 0. That is also true. So in this case, we can have the solutions x, s equal to y, and t equal to z by taking these variable solutions. Z equal to t, y equal to s, we get x equal to 2 minus s minus t. Since s and t are real numbers, we have got infinite solutions, infinite number of values for x, y, and x. That's why we say that this system has got infinite solutions. Moreover, when we graphed it, we know that they all represent the same plane. It lies one above the other. Or you say that it has got infinite solutions. Even with graphing calculator, we can easily check that it has got infinite solutions. So in this video, we saw how to make use of our TI-83-84 graphing calculator to find the solutions for systems of linear equations of order 3, that is 3 equations with 3 unknowns. The same application can be used to find the solutions for equations with 2 variables, or even systems of equations with 4 variables or 5 variables. But for higher results, we prefer using computer or computer algebra system. This graphing calculator is used maybe even for unknowns with 7 unknown variables. Hope this video was helpful. Thank you for listening and thank you for watching this video. Thank you.